Hi, everyone. Thank you so much for joining us today for our live stream on building regression models for the Women in Data Science Datathon 2022. I'm Heather Gore, and I'm joined by Grace. We'll do a quick introductions of ourselves. I am a product manager for MATLAB and work on a lot of data science and machine learning kinds of examples. My background is physics, and I worked on machine learning while I was studying for that. So that's kind of what I do. And I am joined today by Grace.
Hello, everybody. I'm Grace Wilson. I'm a support engineer here at the MathWorks. I have a degree in computer science with a focus on data science and artificial intelligence.
Awesome. So today we're talking about datathons, which, at least for me, these are such a great way to get started on real life examples. You get actual data, you get to build models, try things out. So it's a really awesome way to get started. And we have some links. We'll put many, many links in the chat. You also, in the description, you have the links to the datathon. And also, yeah, maybe Grace, do you want to show that slide? It has, we'll just bombard you with all of the links that we can possibly provide. Because today we're going to follow along with a really excellent tutorial that Grace wrote in the blog post that's linked here. And you can actually run that right in your browser. So you can follow along while she's going through the example. We'll, of course, answer any questions you have, put those in the chat, and we can pause and take questions. And then the other link here is I just wanted to remember that if you need MATLAB, if you want to use MATLAB and you don't have access to it, you can get it for free for the Datathon. You can just follow that link and use it for the competition. So yeah, I guess we should just dive right into it.
Yeah, let's
I
get
think,
started.
yeah, this is good stuff. We got lots to do. I think one of the things I wanted to mention, it's a climate data science challenge in the main Datathon, but we'll be using a different data set to show as an example.
Cool. Thank you, Heather, for that lovely setup. I will be walking us through the tutorial today. So the example that we'll be working with is predicting a vehicle's miles per gallon. So we'll be creating a model to predict that. And the great thing about this tutorial is that it doesn't matter if you aren't too familiar with MATLAB, if you aren't too familiar with regression learning, or if you aren't too familiar with either, honestly. If you've ever tried doing machine learning before, you may know that it usually takes at least a couple hundred lines of code. But I'll scroll down to the bottom and you'll see that we're working with about 63 lines of code with plenty of comments. So this is a great place to get started. Like I said, we'll be working with, we'll be creating a model that predicts miles per gallon. All of our data is in this cardata.csv. So the first thing we need to do is get that data into the MATLAB workspace. You can do this either by clicking import data or by running this UI import line of code and then passing it the file that you want to open. So I'll run this script. I'll run this line right here, I should say. And this opens the import tool. This allows you to preview the data. You can see the name of each variable in the table. You can see and set the data type. I'm going to leave it as default. So we have numbers, categoricals, strings, all different types of data. And up top, you can set import options. So we're working with a CSV, so we'll want to make sure that it is comma delineated. The first row is the variable names. That's correct. We want to import this as a table. We'll keep the name car data. And there are some cells that, when you're working with data, may be unimportable. So if it's empty, if it's a character that MATLAB doesn't recognize, you want to tell MATLAB how to import that. And so we'll stick with the default, which is this NaN or not a number. This is just the default value for MATLAB to tell us, hey, there's no data here. So that's great. We're going to hit import selection. And you'll see that this table is now in our workspace over here. So we can close that. We're good. Cool. Once you have the data in the workspace, we need to pre-process it. And this is two high-level steps. First, we have to clean it up, make sure it's all, organized. It's what we're expecting it to be. And then we'll have to separate it and prepare it for machine learning. Now, the first step for me that I'm going to do is remove the string and categorical variables. As I mentioned before, there were multiple different data types in that table, but a lot of machine learning tools and functions in MATLAB are built specifically for numeric values. So you could choose to convert strings and categoricals to numeric values, but since this is our first model, I just want to start as simple as possible, and I'm going to remove anything that's not a number. So here you
Yeah,
can see.
categoricals are always pesky, I think, especially they're very repeated, the country, the region, there's a lot of overlap there. So yeah, sometimes it's easier just to start simple.
Exactly. Yeah. Start as simple as possible and then change things as you see fit. So here you can see we're left with just these 7 instead of the 12 that we started with, these 7 columns. And then we'll want to handle missing data. So that not a number that I was talking about is our missing data. So before we can decide what we want to do with it, we should take a look at it. So these few lines of code get the indices of all of our missing data. And then we basically squish that together and say, all right, well, I want every row that has any missing values so we can take a look at it. And then this is that table with just our missing values. And if we scroll through, we see that it's only 14 rows long, and all the missing values are either in horsepower or miles per gallon. Since we only have about 400 rows of data, and we don't know how important horsepower is going to be in determining miles per gallon, I'll leave the ones that have a missing horsepower value for now. But you can't train a model how to predict miles per gallon without giving it miles per gallon. So I'm going to remove all of the rows that are missing this response variable or miles per gallon.
Yeah, that's definitely an important one. I was gonna say a lot of the machine learning functions can handle that, some, nans here and there, but not for the actual predictor
Right.
or the response variable.
Cool. And so now we're left with 398 rows, which great starting point. And for mental organization, and again for MATLAB organization, we're going to move this miles per gallon row right here, column, to the end. For mental organization, it's easier to remember which one is the response variable if you have it either all the way at the end or all the way at the beginning. And for MATLAB tools, a lot of times it'll just assume or infer that the final column is that predictor variable. So by moving it now, we're just saving ourselves some headache down the line. So
Yeah, it just makes it easier, less typing later. I also want to add to some of the things that you're doing. You can also click around and do those kinds of things. We're focusing on the code, especially since it's much easier to share. But even, some of the dragging and dropping will actually give you those output pieces of code. So it's kind of nice for exploring like you're doing now.
yeah, absolutely. We've just finished cleaning up our data. So great, step 1, done. And now we need to separate it into training and testing data. So I'm going to introduce that concept a little bit. When you're creating a model, you are essentially teaching a student. That's why it's called machine learning. And so you have to create this training and testing data. Training data, it's like your textbook, it's like your course, the individual class curriculum, it's the things that you are giving your student, the information. Validation data, which isn't mentioned here because it can be part of the training data, in this case it will be, it's like quizzes. You take questions from the curriculum, you give it to the model, and you say, are you learning the things I'm telling you? And it does its best on the quizzes. And then at the end of your class, you're going to need to give it a final. Sorry, students, for bringing up finals, but it's early in the semester. You should be good. So this testing data is like the final. So you'll want to separate your data into that testing and training data. So I'll do that.
Yeah, I like that analogy. I think that's a really good way to put it.
Now you may notice that I separated it by every third observation instead of just, splitting it in half. And that's because when you are, creating a curriculum, when you're training your model, you have to make sure that your data is representative of all the information that your model could be doing, or at least you have to do your best. And if you look at our data here, you may notice, well, that's all 70s. And if you scroll down, you'll notice, oh, now it's 71, 72. And so if you went through all of this data, you'll realize that it's sorted in order of year from 70 to 82. And so if we just split it in half, we'd be training it on the years 70 to 76 and then testing it on the years 77 to 82. And that just wouldn't work because it wouldn't be familiar with those years. So to overcome that challenge, I did every third observation is used for testing and the other 2/3 are used for training. And that would provide our model and assortment of data.
Yeah, I like that, especially for a small kind of data set. You have a lot more control over what's going on. Of course, there's a million ways that you could randomly sample it and,
Right.
try to do stratified sampling and things like that. I can throw a few links in the doc, but, especially when you're actually looking at it, like you mentioned about the years and stuff, it's nice to choose how you want to sort it and split it up.
Yeah.
Awesome. I don't see a lot of questions yet, so I just keep kind of talking. So I guess keep going with the flow and don't hesitate, everyone, to ask anything in the chat.
Yeah, absolutely. Ask us questions. The last thing we need to do for separating our testing and training data, you don't want to give the answer key along with the final. So we remove the miles per gallon variable from the table so that we can separate the testing. Perfect. And now it's not there. It's stored in its own little variable here called test answers. Perfect. The next step is the fun step. You get to train and export a model. And the best part about this is that you get to use it. You get to use the Regression Learner app. The app allows you to train models interactively without having to write any code or even without having to know too much about the different algorithms that the models are implementing. So you'll start by creating a new session. Give me 1 second. Let's try opening this again.
Yeah, I also wanted to point out you're using MATLAB online too, so that's something we didn't mention that before. I think Connell put in the chat, you can also use MATLAB online to run in browser, just like Grace is doing. So that's just one thing to point out. Of course, you can also use your desktop or cloud MATLAB, whatever you like. And yeah, the regression learner is one of those things that I don't know how I did it before. Well, I do know how I did it before. It was a lot of coding and pain in my butt. But it was, it's just the ability to try all sorts of models really, really quickly, especially when you're working on something like a datathon or hackathon where you want to get the best models and maybe you're trying to compete for the big prize. So, using that and training all of them and trying all sorts of things is really awesome. And it definitely saves a lot of time. You don't have to know anything about the models before you just hit go. Um, so,
All right,
it
give
is
me
what it is.
1 second.
Oh, this is good. This is real, this is what happens. It's not responding, close it, start over. That's life. Especially online. I don't know, my stuff is like glitching out today for some reason. It's snowing in
Yeah, the snow.
my world. Maybe we'll blame the snow, blame the weather.
I'm all for that.
The cloud. It's always the cloud's fault.
All right, it's just loading now, but it should be working.
Yeah, this is great. Still not a lot of questions, or none that I see. So please ask questions as you think of them, as you're following along. Must be pretty straightforward, I think, so far, since there aren't any questions yet. She's doing an excellent job explaining. Yeah, so another thing, since we have the screen up here, we mentioned, we're going through the code that we're working on that Grace is showing right now is actually a blog post that's linked here. And so, Connell linked it into the chat. You can actually run that in browser and it goes through all the steps and has some explanations of what Grace is doing. And that, again, kind of the idea is to get you familiar with all those different phases and then you can apply that to the actual Datathon data. And so that's the following link. You can get sort of signed up there. I forget what the prizes are. It's pretty good. I guess I should have that open. But if you actually want to compete, there's some nice prizes as well. And yeah, one of the things I love about it is just being able to look at other people's solutions and scripts and blog posts like Grace says is really helpful to learn.
All right, let's try this one more time. Once you have the Regression Learner app open, thank you for your patience, everybody, by the way.
Yeah.
You want to start a new session. So you will select your training data. So we called it train data, perfect. And like I mentioned earlier, it automatically assumes that miles per gallon is the response variable. So, you can change this manually if you need to, but you'll also notice that you also want to make sure that this is not selected as a predictor variable. So Perfect. And then you also select your validation method. We're going to stick with the default for now, again, keeping our first model as simple as possible, but you may want to consider changing how many folds you do, or if you're working with a larger data set, maybe you'll want to use a different method of validation. And you click Start Session, and it'll load up. And from here, you'll be able to start training your models. Up here on the tool strip, you'll see a model type section where you can click and see all the different types of models that the app can support. And it can be overwhelming, I'm going to be honest. It's a lot of different types of models. You may not know anything about support vector machines, and it can be difficult to know what type of models are going to work best for your problem. So we are going to train all of them.
Just try them all. It's okay.
So you just click on that All button, then you click on the Train button, and the Regression Learner app's going to warm up. It's going to prepare those algorithms, and it will train all of those models in a few minutes. So you can see that it's queued. Larger data set, it may take a little longer, but we're training 24 models with 2 button presses, which I just think is exciting.
It's crazy. Like, why did I get a PhD? All that work. I could just use this app.
Honestly. No,
also, too, I wanted to. Go ahead. Sorry.
I'm thinking of the times that I, made a model by hand, and this is just so much easier.
like tracing out trees. Oh, okay.
Yeah.
I can't think of that. I was going to mention too, since you were talking about bigger data sets and using different hardware and stuff, you can also use Parallel if you it's a little, you have to set it up on MATLAB online with your account, but I have like a 12-core Linux machine here keeping me warm in the snow. And so that's really nice because it just busts through all the models and trains them really fast in Parallel. All right, looking pretty good.
Down to model 22.
Nice.
So real quick, as the models are training, we'll see this RMSE value. That's the root mean square error. And when you're doing regression learning, you can't really be like, oh, is this correct? Because it would have to be an exact number. With classification, if you've ever done that, you can be like, is this the correct category? And that's a lot easier to say, yes, that's correct. But when you're working with regression, you have to be a little more creative, I suppose. And so we're not saying how many values did it get correct, but we're saying how far away is the prediction from the correct prediction. Because the difference of being 0.2 away versus 20 away is going to matter more than is it correct or is it not. And so this root mean square error is telling us the performance of each model on the training data.
Yeah, and I guess it goes maybe to clarify, you want it to be closest to 0. It'll probably never be 0. No, just it's interesting. Sometimes I forget that because I am so used to doing classification, and I'm like, I want 100%, and I'm like, wait, now I want 0 because the visualizations are nice too. I mean, even just you can kind of see there might be clusters of the data that aren't fitting well, so that's really helpful to validate too.
Yeah, and with the app you can compare multiple models at a time. So right here we're looking at a graph for model 1.1, but I want to see the response plot for model 1.18 as well, which is highlighted and is our best performing model so far. So we can see that there's a lot of overlap between the actual and the predicted values. We can plot the predicted versus actual values to see how far away they are from how far away the predictions are from their actual values.
That's good.
So you can play around with this for a little while. But I'm happy with this model if you are, Heather.
Oh yeah, that's a good one.
All right, so this will be our starting model. So I'm going to click Export Model. I will keep the default name, and I will export to the workspace. Do we have any questions so far?
There's one. It's with respect to models, I assume you mean a fit to the data. What type of model will you use and why? So I think that's just to kind of, we can chime in on that. But yeah, that's kind of what we mean, just the best fit to the data model, or I guess that's the best way I can think of to, so it's not a network, it's the machine learning model or I guess the object that contains the
Yeah.
math for it.
Right.
Um,
It's an object that was trained by a series of algorithms.
yeah, good. Excellent. Yeah, so that's that part. And then for the second part of the question was what type of model will you use and why? That's sort of what we're letting regression learner figure out now. But do you have anything you wanted to add, Grace, on, you know, thinking through the models or, some that jumped out at you as better than others?
Yeah, like I said, different models lend themselves better to different problems, and it may be difficult to know which one to choose. So for this one, I chose the one that performed the best on the training data, but that may not always be the case.
Yeah, and it
So
depends on your problem too. Like you said, it really, if usually you know something about the data, so you know kind of what to expect. Like in the app, it has it classified by like nonlinear, linear, or like you can kind of see the mouse over pointers for the different models. And so you can kind of have some sense if you know that your data are definitely not linear, no way, you might be able to just rule those out right away. Although I tend to use linear models anyway, even if I know it's not linear, just because they're easy to interpret. Um, but I think that's kind of the beauty of the regression learner. You can see those patterns. You can see kind of what's going on in the app with the visualizations. So you get a lot more knowledge to be able to choose that way. And of course, for a datathon, the best score wins. So that's, I don't know. I guess it's a good way, a good move to just pick the best performing one.
all right. Any other questions or?
So there's one that just came in. How can outliers influence the results of the predictive model, and how can we reduce outlier influence? So it's a good question.
Yeah. Heather, if you want to start.
Yeah, sure. One thing, definitely outlier, especially, this data was pretty, didn't look too bad whenever we were looking at it, but outliers definitely can have an impact on the model. Again, depending on your data and like what you need, you might want to keep them in there. But there are, in the live editor scripts, you can have these little tasks where it'll allow you to visualize where the outliers are, try to use different methods to fill them or remove them, just the missing data. It's kind of a similar approach. Um, Sometimes I'll do both, where I'll have an outlier model or where I just keep everything in and then I do another one removing them. Um, Also with the, especially with regression, what's the name of it? I'll look at it here. There's one robust linear model does outlier handling within the model. So that's another one to go with right away, because it'll just do that for you and you don't have to worry about removing it. It'll just consider it and you can look at the scores after. So hopefully that
Yeah, and
answers.
I think it's important to keep in mind that it does depend on if you're expecting those outliers to be part of the testing data, I suppose, or like the real world application of your model.
Exactly. And like the one example I use all the time is the cost of earthquakes and hurricanes and those kinds of things. And that one, it's a very, very expensive hurricane. It doesn't mean it's not worthwhile to the model just because it was like $8 billion or something. So, there are times that, thinking about your own data and your knowledge of the problem, can kind of influence how you want to handle that. But like I said, there are many methods. It's kind of like is missing, is outlier, RM outlier to remove, fill outliers. So that should help you out a lot. I think that's pretty much it for now. So I guess we can carry on. I see we've got our trained model, so might as well use it, right?
Yeah. So once you've exported your model, you'll want to take a look at it. I wanted to show you this actual object here. You'll see that it's a struct, which just means it can contain several subsets, basically. And right here, this regression GP is the part of our struct that's holding the actual model. But our trained model object is also including some other information about the model, such as like the prediction function, the variable names, just some other information. But there are going to be some instances where we will need just the model object. So I'm going to extract that into a just model variable. Regression GP, it's regression Gaussian progression. because that's the type of model that we exported, but this may be a different name based on the type of model that you're working with. So if you just take a look at your model by executing the name of your model object, you can investigate and find what you're looking for. Now that we have it, let's evaluate it. So first we'll need to have the model take the final. So we'll send it the test data and we'll capture its responses here. We'll want to calculate the individual error of each prediction, and we could predict the average error, but the problem with that is it doesn't really tell you about the distribution of error. So if overall the model performs really well, but there are like 5 that perform really poorly, 5 predictions, average error will kind of ignore that. It'll just be silenced. It'll be noise, and it'll be kind of, we won't be able to see that in our average error. So we'll want to calculate loss, which squares the error values. So if all of the error values are low, the average will still be low. But if there are a couple that are, outliers that are really high or really low error values, then those will be represented much more because they're squared. And so this is more representative of the performance of our model. So I will calculate the loss here as well. And there's just a built-in loss function. Perfect.
Awesome. I'm gonna say one thing I'll sometimes do is create a histogram of the errors like you calculated there. There's the subtraction, so you can kind of see that distribution like you were talking about. It's nice to be able to hone in on the ones that are not predicting well, or looks good in this case.
Yeah, and we've got some visual representation in just a moment as well. So once you've calculated your loss for your test data, you'll want to check how the model performs on your training data. So compare the loss to your training data. We'll see that here the test loss is 10.16 and the train loss is 1.69. So this may be an indication that the model's overfitting on your training data. So it's learned the training data so well that it can only predict on that type of data. So maybe we need to reconsider how we are dividing up our training and testing data. Maybe the model needs to be tweaked a little bit. There are a couple different things that could be causing this. So we'll go into further evaluation with some plots. First, let's start with something basic. Plot the actual miles per gallon value against the predicted value. This will look a little bit like a chart we saw earlier in the app. And so here we have a visualization. And it can be difficult to identify patterns when you're just looking at a table or a column of error values, because that's just a lot of numbers that you're looking at. But when you put it into visualization, you can start to identify patterns. And patterns are what is going to allow you to further fine-tune your model. So here we see, okay, well, on this end, it seems to be performing pretty well. But once we get about past 30, we have some pretty dramatic increases in error values. So let's take a look at, how many values in our training data have an MPG above 30. Let's look at that. And you can just use numel to count, and you'll see that we have 54. But we have about 260 rows in our training data. And so 54 is only 20%. But if you look here, values between 30 and our max of about 45 should make up more like 40% of our data. So we might just not have enough data in our training set, that's representative of this area. That could explain why it's performing poorly. Let's also look at the actual error, or in this case, we could call it residual values, as this can give us a different perspective on the errors. Like we saw above, pretty dramatic on this side. But we can also get a better sense of, okay, at what point is the error more than the average error? So, it's pretty centered around here, but these two and these ones are a little further, and then all of these ones are a little further. So let's say any error above 5 or below -5 is too much. That is like something is wrong. So let's take a look at our test data that has an error of, the prediction has an error of greater than 5 or less than -5. At first, it may be a little difficult to identify patterns, but if you take some time looking at your data and at your training data, you might start to notice some patterns. This weight value is smaller than the minimum in our training data. There are 4 values in year that are 1980. We've got a couple that are missing horsepower. A lot of these displacement values are pretty low. We've got a 3-cylinder and a 5-cylinder, which just aren't really represented in our data. And so these are all patterns that we could start to notice and say, okay, maybe we need more data. Maybe we need to change the distribution of our testing and training data. Maybe there's something we need to change about the way our model is weighted.
Right. Or even bringing back some of those categoricals, maybe the region will help, figure out some patterns, and could even improve the model. But those are the kinds of things after you kind of take that first pass, I feel like then you can start really thinking or really digging into the problem, see what's going on.
Absolutely. Yeah. So one of the things I mentioned was that a lot of the displacements here seem to be pretty low. So based on this pattern, I'm predicting that on average, the displacements, the rows that have a low displacement will also have a higher degree of error per their miles per gallon. So I'm going to plot the residuals or the error against displacement and see if this is true. Sure enough, it sure looks like, over here we're kind of flattening out, we're a little more steady, but over here the errors are all over the place. And so again, that might indicate that we need to shift up our training and testing data, change the model. So these are all things to keep in mind as you're testing your model. And from there, you rinse and repeat. The coolest thing about machine learning is that you're not supposed to get it right on the first try. It's not like, I've done the process, I'm done. You have a model, you test it, you see what's going wrong, and, from there, you change it. You change your test data. You open the app again and test different models this time, or you change the parameters, or you add, like Heather said, you add the categorical and string variables back, but maybe you tweak them into numbers, or there's so many different ways that you can do this. So I recommend that you save a model if you like it. I saved it. I changed the variable name to model 1 because it was our starting one, but maybe you would call it something different. And then you can just type save model 1. And if you do that, it'll appear right here. And you can load that back into your workspace at any time. So you've got it saved. You can clear your workspace, create new variables, change things up, and just keep going until you have a model that you're happy with.
Perfect. Yeah, that's great. Just a couple of questions. I think they're pretty related to what we're talking about. We can maybe take those if you want.
Absolutely.
Awesome. All right. One was how can we use parallel processing? And so we mentioned that quickly. It just kind of showed in the app. There's a little thing that you can hit a button, assuming you have multiple cores and workers available. And otherwise, whenever you're training outside of the app, you can also, most of the models have, I don't want to say all, because I don't, it seems dangerous, but I believe most, if not all of the models have an option where you just type use parallel true. And that just takes advantage of the resources that you have available to you. You don't really need to do anything special. It's very, very easy to do that as long as you have that hardware available. And then, of course, you can tweak that. I will send a link. I'll put a link into the doc to get started with that.
Yeah.
Another, let's see. So it was, can this be used to determine the influence of various measured parameters of data on one particular measured set of data? Um, I think I understand. So if I understand right, I guess it's sort of in this phase that we're in now, kind of going back and understanding how the model is operating or what, just like you were doing, you realize that displacement has something to do with all this, and there's some values that were out of whack or something. So just sort of using, I don't know, like brute force, just using changing the variables that you have in your data set. Um, Otherwise, I'll put a link into the chat as well. But there's a interpretability page where there's a lot of methods like Lime. I'm trying to think of some of the other ones like Shapley value. Some of them are not appropriate for all different models, but those will give you a lot of insight into what variables were being very influential or not. And there's some nice visualizations and things like that too. So that I think hopefully that answers the question. Anything to add, Grace?
Not that I can think of. I think you said it well. Also, if you're looking to I meant to open the app again. I meant to show this. But in a regression learner session, you can investigate the relationships between data, between the various variables and the predictor variable, sorry. So like if you look at displacement here, there's like a distinct pattern that you can look at, whereas cylinders, not so much. If you look at horsepower, distinct pattern again. So those are some relationships that you can look at from the app as well.
Yeah, definitely helpful to visualize as much as possible. I think, at least for me, that's one thing that helps the most.
Absolutely.
The other thing too, like even just with your data set, you can always poke around in the desktop. There's a plot tab. And so that can be helpful even in the first steps, just trying to figure out what you're working with. When you have your data selected, you can kind of see, or even if you don't have it selected, you can just see all the different plots that might be useful to you. I don't see any other questions. We should probably give another minute or two for people to think of some questions. But so far we're doing all right here. No big questions, but please don't hesitate. Yeah, so I guess was there any other parts of the code that you wanted to talk about or anything before we sort of wrap up?
I think that's it. It's a very simple start. It's an iterative process. So
awesome. It's a great starting point.
Go to the blog post and get started.
Yeah, definitely. And the blog post has links to all of the right places to get the data, to sign up for the Datathon, to claim your fabulous prizes, and get MATLAB if you need it. So feel free to check that out. Oh, okay, I see. So there was a clarification on the last question. It was, maybe I misunderstood the training data. Can you do it without preliminary knowledge of influence? If that makes sense. I think if I'm understanding it right, I think that's generally what the models will do. They'll kind of assess the influence in most cases as they're training. So that isn't too big of a deal. You don't necessarily need to know the relationships between the variables or if there are any, especially with a datathon. Sometimes you just start, it's not your data. So I just tried all of it. But then other times, if you know for sure, like if something's calculated from two other variables, that's probably not a good idea. You just need that one. So I think those initial steps, you don't really need to have some special representation of your data, but you should probably use your brain a little bit to make sure, you're not having overlaps in what information you're giving the model, if that makes sense. Anything to add
totally
on
agree.
that?
No, totally agree. I think you put it well.
Yeah, it'll definitely help figure out the relationships. I guess that's kind of the goal in a lot of cases.
Right.
All right. Let's see. That's about it. No more questions here. So I think we can wrap up. Of course, if you have questions later, we can always monitor the comments and answer anytime. So don't hesitate to keep in touch. And we hope you join the Datathon and win, I guess, if that's what you want. And, learn, especially. That's the most important thing.
Go forth and learn.
Indeed. Thank you so much, Grace. That was excellent. Example was really well done. I think it was a great, clear, nice example to talk through all those different phases. So thank you so much for sharing.
Thank you, Heather. And again, I just want to really encourage the blog post. There are a lot of resources linked in there. Everything I said is explained. All the code is explained. So if you want to keep working with MATLAB, or if you have any more questions about this afterwards, I'd recommend starting there.
Definitely. And there also will be another follow-up workshop. It's in about a month. We'll share links to that, but we'll be going through a similar kind of process, really hands-on and, walking through step by step. So don't forget about that. It's going to be February 27th. All right. Thanks everyone so much. Thank you so much for joining us. This is great.
Thank you.